In this presentation, we are going to look at a linear algebra proof. So suppose that A is an n by n square matrix. Now, just as a remark, for most of the subjects that this proof is relevant for, the subject matter only goes up as far as 2 by 2, 2 by 2 or 3 by 3 matrices. So that the sort of standard proof we're sort of showing here would suffice in that case. It's sort of more at school level and junior cycle university level than sort of high-end mathematics. Essentially what we're asked to do here is, so just bear that in mind. So essentially what we're asked to show here is show that the determinant of k a equals k to the n times determinant of a. So determinant of k times a is, this is just a scalar multiple of a, and the determinant of that, okay, and that is equal to the determinant of a times k to the power of n. Now just be clear, n is with the dimensions, it's the number of rows or the number of columns for the square matrix. Okay, so let's get cracking here. So what we're going to do here is just actually get the determinant of a and get an expression for that. I'm going to do this very quickly. Essentially what we do here is take the top row, or well, any row, but I'm going to take the top row, and that is in a plus position, according to the sign array, plus, minus, and plus position. Okay, so it is A times the determinant of its submatrix, and in this, for the case of A, that would be EI, or E times I minus H times F, EI minus HF. Then the next one is for the submatrix for B, and that is essentially these two elements here and these two elements here, and so that's minus B times D times I minus G times F. Okay, and finally the submatrix, the determinant of the submatrix for C. The determinant of the submatrix for C is DH minus DH minus EG, okay, or GE, doesn't really matter, and that is it. And again, the C is in a plus position according to the sign array. So let's solve that out. Now it's a big long phrase here. So AEI minus AHF minus BDI plus BFG. I'll just try and keep each of these phrases in alphabetical order, plus CDH minus CEG. Okay, so that's the determinant of A. Okay, now what we're going to do is get the determinant of k times a. So let's have a crack at that one now. So here I have it again. So we're going to do something very similar here. Take the top row, and what we have here is k times a minus, let's get the determinant of its submatrix, k times e times k times I minus k times h minus k times f. Okay, plus k times b and determinant of its submatrix, which is this part and this part here. Oh, sorry, and that's in a minus position according to the sign array, so we've got minus there. So k times d times k times I minus k times, I'm going to keep it in alphabetical order according to what is in the A matrix, and finally plus k times c, and that is the submatrix for C is what I have highlighted here now, and that is k times d times k times h minus k times e times k times g. And again, I'm sort of picking out alphabetical order there, well, apart from the k obviously. Now I'm going to sort of simplify all of that. So we have k times a and k squared times e times I minus k squared minus h times, or k squared minus h, k squared times h times f. Okay. And what I'm going to do is square that. I'm going to sort of fully, well, actually, I'll just keep going with the rest of it here. Just do it out fully. Minus k times b times k squared di minus k squared fg plus k times c k squared dh minus k squared eg, and so on. And when I take a multiply through the k terms, or multiply each term is on its own, what I have here is k cubed times aei minus k cubed ahf minus k cubed bdi plus k cubed bfg plus k cubed cdh minus k cubed ceg. And essentially that is k cubed times aei minus ahf minus bdi plus bfg plus cdh plus ceg. And that is, oops, gone a bit too far there. Essentially, you probably guessed it now. That's k to the power 3 times the determinant of a. And that will do us. Now, again, this sort of proof is, you can do this for a 2x2 matrix. A 3x3 matrix is usually as big, or the proofs will sort of say you can sort of use a 3x3 matrix because it's sort of what they generally use in school and first engineering programs and so on. Okay.